example now, they wanted to use this for us to solve some equations. So let's say we needed to solve some equations here. So let me erase this. Let's say they gave us that log base 5 of x is equal to 3 log base 5 of 2. Keep in mind, this is just like when we are solving regular equations. We need to isolate, and I call it isolate, the log base 5, meaning that we need to get it to say log base 5 of something equals log base 5 of something. This 3 shouldn't be here. So we're going to say log base 5 of x, that one is fine on this side, equals log base 5 of 2 cubed. Log base 5 of x equals log base 5 of 2 cubed. Well, we know what 2 cubed is. Log base 5 of x equals log base 5 of 8. Well, one thing we know just using our common sense, if log base 5 of x is equal to log base 5 of 8, then x equals 8. But really what we're doing is that to get rid of this log, there's one of the log rules where it says you raise it to the power of the log. So what we're going to do is 5 raised to the power of log base 5 of x equals 5 raised to the power of log base 5, and I got the 5 because it was in 5 of 8. These simplify down to 1, giving us x equals 8. Let's do another example. So log base a of x equals 2 log base a of 3 plus log base a of 5. And just like I said before, in order to solve logarithm equations, we need to get a log base a of one number equals log base a of another number. One log equals one log. You can't have two logs here. And you can't just factor out the log. So we need to condense it into one cohesive log. This is already condensed. So this is just log base a of x. We need to condense this. The first thing is for me to move this back to the front as an exponent. So this is going to be log base a of 9, because 3 squared is 9, plus log base a of 5. In the log world, addition, when you condense it, becomes multiplication. So log base a of x equals log base a of 9 times 5. Log base a of x equals log base a of 45. Now we take the a of both of them, a raised to the power of log base a of x, and we don't need to know what a is, a raised to the power of log base a of x. Those go away, giving me that x equals 45. Let's do a third one. Let's do one that looks like this. Log of x minus log of x plus 3 equals log of 1 minus log of 10. Ooh. Keep in mind, to solve, it has to be 1 log, and this is all in base 10, equals 1 log. Log equals log. So first I need to condense this, and because it's subtraction, it needs division. So this is log of x divided by x plus 3 is equal to log of 1 over 10. Subtraction means division. Now, because this is a log equals a log, and this is base 10, since we don't see anything, 10 raised to the power of this and 10 raised to the power of this whole thing, that goes away, this goes away, leaving us with x over x plus 3 equals 1/10. And then we can do a little cross multiplying. So I have 10x equals x plus 3. 9x equals 3. X equals 1/3. So this now, x equals 1/3 is my answer. We can do one more, and then we'll move on into solving exponential equations. Let's do this one here. This one looks interesting. It says log base A of x equals 3/2 log base A of 9 plus log base A of 2. We need to get log equals log. So this one is fine, no condensing here necessary. Is equal to this 3/2 means it's the exponent of that. So that's log base A of 9 raised to the power of 3/2 plus, there's no exponent, anything, log base A of 2. Well, 3/2 means the square root of 9 raised to the power of 3. So log base A of x equals the square root of 9 is 3. 3 raised to the power of 3 is 27. So log base A of 27 plus log base A of 2. Because we're adding, when we condense it, we're multiplying. So log base A of x equals log base A of 27 times 2. So log base A of x equals log base A of 54. Log base A, we say A raised to the power of this, A raised to the power of that. This now becomes the exponent, but this cancels out, leaving me with x equals 54. And this is how you solve logarithm equations. We condense, whoops, my lights went off. Let's turn that off. So now sometimes what may happen is that they may ask you to simplify something, but it's in two different bases. Or you may not be able to solve it because our calculator is only in base 10 or base E. So let's say you have something like this, and I'll give you one that we already know so that you can compare it. This is called the change of base formula. Change of base formula. So let's say you have something like log base 2 of 8. And luckily for us, we know log base 2 of 8 is 3. But let's say we didn't know what log base 2 of 8 was, and we wanted to do it on our handy-dandy calculator. Well, something called the change of base, where we can change it to a base of 10. The rule of change of base, and I'll write it here, is that log raised to, and let's just say, let's write b here and a here, is equal to log of a in base 10 over log of b in base 10. So using this rule, this means that log base 8 in base 10 over log base 2, and not 8 over 2, you have to do the log of 8 in base 10 divided by the log of 2 in base 10 will give you your answer. So we're going to try it on our calculator. And let me bring my calculator close by. So now here's what I do. Let's bring it here. I'm going to hit the log button. Log of 8. There's log of 8. Divided by, and I put this in parentheses because it's divided by the whole log. You have to type another log in. Log of 2. Close parenthesis. So I said log of 8 divided by log of 2 equals 3. Change of base says that if you're dealing with a base, If you're dealing with a base that you're unsure of how and it's not in the calculator, you can do a change of base form. So that's, for example, let's say you have something like log base 7 of 320. Well, we don't know what this is, but we can quickly evaluate this. This isn't one of the simple ones like that. We just know it's the log of 320 over the log of 7. And you have to do the log separately. So log in base 10, we're changing the base from 7 to 10. Log base 10 of 320 divided by log base 10 of 7. And then we will get our answer of what 7 would need to be raised to the power 2 to give us 320. And I'm going to do that on my calculator. And then I'm actually going to raise it to the power to see if it works. So let's say, for example, right now, I have log of 320 divided by log of 7, and you can try it yourself. And I'm going to get an answer. The answer is 2.96433 and so on. So that means 7 raised to this power should give us 320. So I'm going to say 7 raised to the power of the answer that I got. So let's show you. 7 raised to the power of the answer that I got. Enter 320. So that's the change of base form. Sometimes you may need to do the change of base form. If you have your log in a form that doesn't work on the calculator, you can quickly change it to a base of 10 and evaluate your answer. Let's change of base form and solving log equation. Last but not least is now going back to how we solve the compound interest when the time is missing. So now that we know how to get the exponents by using the logarithm rules, let's see if you have a question like, and I need an example. So here's one of the questions. It says 500 is invested at 6% annual interest. So our initial amount, 500. And it's invested at a rate of 6% annually. Compounded quarterly. That means it's done 4 times a year. When will the balance double? So when will we get a double? When will our Y, our output, equal double what we got? So when will our output be 1,000? So we say 1,000 equals, and now we use our formula. Don't forget yesterday the formula we talked about is A times 1 plus R over N raised to the power of NT. R rate, N number of times in a year, N number of times in a year, times T, which is in years. So then A was, we started with 500. 1 for the 500 plus whatever our interest is, so 6%, 0.06 over compounded quarterly, so 4 times a year, raised to the power of 4, and T, because it says when, we don't know when, we want to know how many years, so T. So then we go ahead and solve. First thing we do is that we're going to divide both sides by 500 because we want to isolate this. So divide by 500, divide by 500, I get that 2 is equal to 1, and this is in parentheses, plus 0.064 raised to the power of 4t. Now I need to do what's inside the parentheses, so I'm going to do what's inside the parentheses here. So 1.1 plus, in parentheses, 0.06 divided by 4, close parentheses, equals. So I have 2 is equal to 1.015 raised to the power of 4t. In order for me to bring down this exponent, I needed to say log base 2. So I need to do the log base 2 on both sides, because remember, if you do the log base 2 of both sides, then you will be able to cancel out this side. So I say log base 2 over here and log base 2 over here. Because this is log base 2, and this now becomes the exponent of the number, this goes to the back, This, the exponent is 1, so that cancels out, just giving you 1. So 1 is equal to, and then this gives me 4t log base 2 of 1.015. Now we can't do this in our calculator, so we can do the change of base. This is actually going to give us a number. So then we're going to get our number here. So 1 is equal to 4t, and our change of base will give us, I'm going to do log of 1.015 over log of base 2. Oops. Okay, so log of 1.015 close parentheses divided by log of 2 close parentheses equals a number. I'm going to say 1 divided by that number. So 1 divided by this, it's just the reciprocal. So log base 2 of then, because when you divide by or you multiply by the reciprocal on both sides, now I say log base 2 divided by log base 1.0, well not base 15 close parentheses equals 46.55. So 4t is equal to 46.55 continuously. Divide by 4. 11.t is approximately 11.64. And we're going to see if that's actually true. So that's saying in 11.64 years, it's going to double. Let's see if that's true. It's compounded. So we're going to put this back in, 11.64, into our original equation and see if that actually works out. So let's go ahead and test it to see if it works out. Our original equation says 1,000 is equal to 500 raised to the power of 1 point, and I'm just going to say 0.015 raised to the power of 4 times 11.64. And 1.015 is just this right there. So I'm going to do this portion first, 1.015 raised to the power of that. And then multiply that by 500. And we get something really close to 1,000, but because it was an approximation, that's why we got 0.066 over there. So that means it's going to take us approximately 11.64 years in order for this $500 to double to 1,000. Let's do a second example just to drill it home. A population of 450 animals decreases at an annual rate of 16% per year. So we have a population of 450 animals. So that's our starting value. And it decreases at an annual rate of 16% per year. A year. How long, so the question is time, so we don't know t, before there are only 100 animals left. So how long before our output is only 100? Now this one, they didn't say compounded annually, they didn't say compounded monthly, they didn't say anything. So this one, our n is going to be 1, because that means they only do it one time. So it's 16% divided by 1, so just 16%. So I'm going to go ahead and say, when will 100 equal 450? And because they say it is decreasing, 1 minus our 0.16, raised to the power of t. N is 1 in this case, so we can just do it like that. So 450, now we're subtracting 16%. That means there's only 84% left. So when will 100 equal 450 times 0.84 raised to the power of t? We divide both sides by 450. Now let me divide by 450. Handy dandy calculator. 100 divided by 450. When I got a number, I'll just say 0.22 because I have to approximate, is equal to 0.84 raised to the power of t. Now that we have this, we need it, and I'm going to do 0.22. I'm going to take the log of both numbers, and we can just take the natural log of both numbers if we want. So the natural log or just the log of both numbers. So I said the log of 0.22 equals the log of this. So now log of 0.22 is an actual number. So you can go ahead and find the log of your answer. So log of that answer is negative 0.653 approximately. And this t comes to the back. T log of 0.84. So now we need to find what 0.84 is, because then we're going to divide. Log of 0.84. And that gives us a negative number. So t times, and I'm going to just approximate here, but if you can avoid approximating, that's even better. If you can't avoid approximating, try to use 4 decimal places. The more decimal places, the more accurate your number is going to be. I only use 3 here, but that's okay. So divide both sides by that number. So I'm going to take the first number I had before, so that's this number, and then divide by my answer that I got, and I get t is equal to 8.63 approximately. So that means in about 8.63 years that this 450 animals will only have 100 left. In 400, and these 450 animals will only be 100 left if they're decreasing by a rate of 16%. If we're subtracting 60% of it each year in 8.63 years, it's going to, and we can go ahead and check if that's correct. So I'm saying that if I do this, plugging in 8.63, I will only have 100. So I'm going to say 0.84 raised to the power of, and we're saying 8.63 times 450, and we only have 100 left. It's very close. So that is how you solve, and let's do just one more. Let's do one more. I know you guys are all, let's just do one more just to see. Let's do one that's compounded more than once a year. So let's see. Monthly. 2,000 is invested, so my initial is A, 2,000 is invested at 7% annual interest, so 7% annually. And then it's compounded monthly, so that's 12 times a month, 12 times a year. When, so T, will the balance triple? So triple of this, when will my output be 6,000? When will it triple? So then I go ahead and say 6,000 is equal to, and our initial amount was 2,000. 1 plus our rate is 7%, so 0.07 over our number of times annually, so that's 12 times annually, raised to the power of 12 times annually, and we don't know what t is, so 12t. Divide by 2,000, so I have 3 is equal to 1 plus 0.07 over 12 raised to the power of 12t. Then I actually do inside the parenthesis. So I say 1 plus in parentheses 0.07 divided by 12, and I get a number. So it says 3 is equal to, and I'm going to approximate, so let's approximate, even though if you can find a way not to approximate, even better. So 1 point, if you have to approximate, use at least 4 decimal places, 1, 2, 3, 4. So 5, 8 raised to the power of 12t. Now because it's a number equals a number to an exponent, we can take the log of both sides. So log of 3 is approximately the log, and we can just take the log of both sides. No change of base necessary. Log of 1.0058 raised to the power of 12t. Because this is an exponent, it goes to the back. So log in base 3 is approximately log of 1.0058, and the 12t is over here. Divide both sides by that. So log 1.0058 is equal to 12t. Because 12t is there. Let's just do it so it doesn't confuse somebody. Leaving me with 12t. And then I go ahead and do this, and once I'm done with that, I divide by 12 to get t by itself. So log of 3 divided by log of 1.0058 close parenthesis equals, and then I'm just going to divide that by 12 in one shot so I don't approximate. 15 points, so they're saying t is approximately 15.83. So that means in 15.83 years, 2,000 will become 6,000 if it's being compounded annually at a rate of 7% compounded monthly. 15.83 years. And that was the last thing that we needed to do.